Alright, so for the do now question, that is just a matter of typing that into your calculator exactly how it appears. So you got to make sure that you type those parentheses in there also. And if you type that all in correctly, it should come out to 2/5. Alright, so the packet that you picked up today is a review for your Q1 assessment, which is going to be on Wednesday. I know that's quick after we just had a test. But the other option was to start a new unit, get partway through it, and then stop that to review for the Q1 assessment. So this just seemed like an easier plan. So there's only 2 topics on the test. It's rational numbers, which is what we did first, and then it's the proportional relationships, which you guys just took the test on, so we just got finished reviewing all of that stuff. So the first thing that we're going to look at on here is converting between fractions and decimals, and pretty much you're just going to use the calculator for this. But to write a fraction as a decimal, we just divide. So for example, if I wanted to write 1/5 as a decimal, if I had to show the long division, step 1 is just divide the numerator, the top, by the denominator, which is the bottom. So this is where you just picture that you tip it right over on its side. So the 1 would end up on the inside, and the 5 would end up on the outside. Now 5 can't go into 1, so I'm just going to add a decimal and a 0. And then I'm going to bring the decimal straight up into my answer. And now I just need to see how many times can 5 go into 10. Well, that goes in there twice. 2 times 5 is 10. So my answer would be 0.2. You can also do this on the calculator. Hopefully you remember how to do that, but you're pressing second PRB. Alright, so for example, it says convert 0.8 to a fraction. So this works for either going from fraction to decimal or decimal to fraction. So I'm just going to press 0.8, second PRB, and that tells me that the fraction is 4/5. Now for the one at the bottom here, it says which fraction is equivalent to 2.6 repeating. Well, I can't type a repeating decimal into the calculator, so my other option here is going to be to take these answer choices, type them into the calculator, and turn them into decimals, and then I'll be able to see which one comes out to 2.6 repeating. So I'll take my first one, 2 and 1, 6. So I'm going to press 2, ABC1, ABC6, so that's 2 and 1, 6, and then second PRB. So that tells me it's 2.16 repeating. That's not. So then I try the next one, 2, ABC2, ABC5, second PRB. 2.4, that's not what I want. So then I do 2 and 1/3. Oops, second PRB. And that's not what we want. So then 2 and 2/3. And that comes out to 2.6 repeating. So that 7 at the end is only there because your calculator is going to round the last digit. So this really is 2.6 repeating. So that's going to be choice D. The next thing we're going to look at here is adding and subtracting integers. So the big thing with the adding integers, since you're using the calculator, the rules for adding integers aren't as important. The big thing that's important to remember is anytime you add a number and its opposite, you get, so you'll see word problems like this where it's asking you which is going to result in 0. You're looking for whichever situation is going to end up where you're adding a number and its opposite. So here it says the temperature after a decrease of 5 degrees from a temperature of -5. Well, if you picture a thermometer, if I'm at -5 and then I go down 5 more, that's not going to put me at 0. The height of an airplane after taking off from ground level and rising 1,000 feet. That's not talking about adding a number and its opposite. The amount of money received in change after making a $10 purchase with a $20 bill. Also not talking about a number and its opposite. And then the last one, the distance above sea level after increasing 24 meters from a depth of 24 meters below sea level. So 24 below sea level would be -24. If you're increasing 24, then you're adding 24. And now you can see we're adding a number and its opposite. That's going to leave us at 0. So that's choice D. For subtracting integers, same kind of thing where we're not too concerned about what the answer is because we can just type that into our calculator. The calculator will do it for us. The type of questions that you have to be able to answer are things like this. What's an equivalent expression? So it says when we subtract integers, we rewrite the problem as addition using keep, change, change. All right, so for example, negative 12 minus 4. If I just want to rewrite this as addition, I'm going to keep the negative 12. I'm going to change subtraction to addition, and then I'm going to change the sign of the second number. So this is a 4. I'm going to change it to a negative 4. Okay, so that would become negative 12 plus negative 4. So now for the next section, again, rewrite each of the following using addition. So keep, change, change. So I would keep the 3, change subtraction to addition, and change 8 to negative 8. Keep the negative 2, change subtraction to addition, change negative 7 to positive 7. And then keep the 10, change subtraction to addition, change negative 5 to positive 5. So that's what you need to be able to recognize for the test question. So it might give you this and say, which expression is equivalent to this? You need to be looking for the keep, change, change version. The next thing that we're looking at here is the distance between integers. The easiest way is if we have a number line like this and we can just count. So it says, what's the distance between point A and point B on the number line below? Well, I'm just going to start at A, and I'm going to count until I get to B. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. So that would be 13 units. The harder questions are where we can't realistically count on a number line. This one says, a hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. He hikes to a location on the trail that's 580 feet above sea level and stops for lunch. What is the vertical distance between 200 feet below sea level and 580 feet above sea level? So this is where we said we could use a number line model without actually counting each space. So I'm going to draw a vertical number line here. I'll put 0 right in the middle. So it says that he starts at a point that's 200 feet below sea level. So if 0 is sea level, 200 below is going to be down there. And then he ends up at a point that's 580 feet above sea level. So that's going to be a positive. That's going to be up there. We want to know what's the distance between these 2 points. So if I break it up, well, I know from 0 to 580, that's a distance of 580. And then from 0 to 200 below, that's a distance of 200. So my total distance is going to be 580 plus 200, which is 780. The other way to do that was using the formula, absolute value of P minus Q. This will give you the distance between any 2 integers. So I would just plug in my first number for P, so that was 200 below, so negative 200 minus, and then my second number for Q. I subtract these, so I can use the calculator to subtract those. So negative 200 minus 580 gives me negative 780, but it's the absolute value of negative 780, which is positive 780. So same answer. All right, so we'll look at one more very similar kind of question. So it says, Daryl and Keith solved the problem below. If the temperature drops from 7 degrees Fahrenheit to negative 17 degrees Fahrenheit, by how much did the temperature change? So we want to know what's the distance from 7 to negative 17. So it said Daryl said the temperature change is 24 degrees. Keith said it was 10 degrees. Who is correct? So I'm just going to use my number line model again. So I'll put 0 in the middle. If we're starting at 7 and then we're going to negative 17, we want the distance between those two. So I'm going to break it up again. I know to get from 0 to 7, that's 7. And I know from 0 to 17 below, that's a distance of 17. So if I add those together, that's going to give me the total distance. So 17 plus 7, that's 24. And so we want to say who is correct. Well, it said Daryl said that it's 24. So we'll say Daryl is correct. And then we showed our work right here. The only other thing with rational numbers is word problems like these ones where you're talking about, usually it's about changes in temperature. So we'll just go through a couple key phrases here to let you know how to set up your problem. So the first one is 30 below 0. So if we're talking about below 0, that's talking about a negative number. That's negative 30. The next one, if the temperature rose 10 degrees, rose means it's going up, so that would be you're adding 10. If the temperature is dropping, it's going down, that's subtraction. So if it dropped 20 degrees, that means subtract 20. And then the last one is a little bit tricky, average temperature change per hour. So if you have a question asking you, what's the average temperature change per hour, okay, that's like the unit rate, change per hour. So it's the change divided by the hours. So the change is how much did the temperature change, and then the hours is how long did that take. All right, and then we divide, because like I said, it's a unit rate, change per hour. So let's look at our first question. So it says at 7 a.m., the temperature was 5 degrees below 0. By 3 p.m., the temperature rose 25 degrees, and by 9 p.m., dropped 8 degrees. What was the temperature at 9 p.m.? So I'm just going to go step by step through this problem. So first of all, step 1, what's the starting temperature? Well, it says at 7 a.m., it was 5 degrees below 0. So we said below 0 is a negative. So our starting temperature is negative 5. By 3 p.m., the temperature rose 25 degrees. So step 2, what does rose 25 degrees mean? Well, we said up here, a rising temperature, that means we're adding. So we need to add 25. And then by 9 p.m., it dropped 8 degrees. And again, we said up here, dropping is subtracting. So we're going to subtract 8. So now, you can just type this right into your calculator. Make sure you're using the negative button for this negative 5, not subtraction. So I'm going to type negative 5 plus 25 minus 8. All right, and that tells me it's going to be 12 degrees. And the one at the bottom here, the temperature one day in Johnson City fell from 26 degrees Fahrenheit at noon to negative 10 degrees Fahrenheit at midnight. What was the average temperature change per hour? So that's what we were talking about right here. Average temperature change per hour is a unit rate, change per hour. So how much did it change? Divided by how many hours? How long did that take? All right, so it's change divided by hours. So what we need to figure out first is how much did the temperature change? Well, it said it went from 26 degrees at noon to negative 10 degrees at midnight. So you can kind of use that line model again. So if we have 0 here, it started at positive 26, it went to negative 10. We want to know how much of a difference is that? What's the change? Well, from 0 to 26, that's 26. And from 0 to 10 below is a change of 10. So if I add those together, my temperature change is 36 degrees. Now I need to divide that by the number of hours because we want change per hour. So it says that it fell from 26 degrees at noon to negative 10 degrees at midnight. So we need to know how many hours is it from noon to midnight. So if you're not sure, you can count hour by hour. Okay, just use your fingers, add it up. But that's 12 hours. From noon to midnight is 12 hours. So I'm going to divide that by 12. So now on my calculator, I'm just doing 36 divided by 12, okay, which is going to be 3. Now the trick here is, it says, what's the average temperature change per hour? So when we're describing the change, we need to describe whether it rose or it fell. So here, it fell from 26 to negative